So let's understand the theory for this half adder. So this is the circuit diagram for this half adder. As we have two inputs A and B and two outputs sum and carry. So these two inputs A and B is passing through this XOR gate. Then expression for this sum is A XOR B. So how we can write this XOR? A bar B plus A B bar. You need to remember this expression. Okay. And for carry, these two inputs is passing through this AND gate. So carry is A and B. Okay. So this is the circuit diagram for this half adder. Now let's understand the truth table. So we have two inputs A and B. Okay. So what are the possible combinations? 0 0 0 1 1 0 1 1. Okay. So these are the possible combinations. So for sum, according to this expression, for 0 0 case, sum is 0. For 0 1 case, it's 1. We need to just perform this XOR operation. 0 XOR 0 0, 0 1 XOR 1, 1 XOR 0 1, and 1 XOR 1 is 0. Okay. So this is for sum. And for carry, we need to perform just AND operation. So 0 and 0 0. So that's why 0. 0 1 0, 1 0 0, and 1 1 1. Right. So this is for carry. So this is about half adder. Next we are writing Verilog code for this half adder.
Okay, so let's write Verilog code for this half adder. Here I already declared one module for half adder. Now let's initialize inputs and output ports. So these are our input and outputs. A, B are inputs and sum and carry are the outputs. Okay, now let's write it here. Input A comma B, output sum comma carry. Okay, in this half adder module, I am using data flow modeling. So I already discussed the expression for this sum and carry. So I am writing those expression in this data flow modeling. So how we can write? First we need to write assign sum equal to, what is the expression for this half adder sum? That is A XOR B, right? And for carry, assign carry equal to A and B. Okay, so these are the two expressions for this half adder, sum and carry, and at last end module. So this is the Verilog code for this half adder module. Okay, so our syntax is correct. So that's why it's showing green. Let's save it and write the testbench for this half adder. Now let's create one file for testbench. Okay. So in this simulation sources, our testbench file is there. Okay. So as we know, for input we need to write range A comma B, and for output we need to write wire sum comma carry. Okay. Next, so which module we are using for this testing purpose? That is half adder, right? So I wrote HA, then design and test. Next, A comma B comma sum comma carry. Okay, these are the inputs and outputs for this half adder module. Okay. Next, write initial, begin and end. So in this begin and end, we need to write inputs, right? So initially A equal to 0, B equal to 0, and after 10 seconds A equal to 1, A equal to 0, A equal to 0, and B equal to 1, and then after 10 seconds A equal to 1, B equal to 0, and then after 10 seconds A equal to 1, B equal to 1. Okay, then after 10 seconds finish. Okay, done. So if you have only two inputs, then these are the only four possibilities: 0, 0, 0, 1, 1, 0, and 1, 1. Okay, so we are checking all these four possibilities and we are observing sum and carry. Okay, so as we discussed in theory, sum and carry results based on these inputs, it will come. Okay, so let's save and we, observe our simulation. Run simulation. So this is the simulated result. Now let's see here. For 0, 0 case, sum is 0. First we observe this sum. For 0, 0 case, sum is 0. For 0, 1 case, sum is 1. For 1, 0 case, sum is 1. And for 1, 1 case, sum is 0. Okay, so our sum is correct. Means whatever we expected, it is coming here. Right? In carry case, for 0, 0, 0, 0, 1 is 0. For 1, 0 is 0. And for 1, 1, it's 1. Right? So this is also correct. Okay. So in this way we can write this code and test bench for this half adder and we can observe in this simulation. Okay, so here I wrote in this data flow modeling, you can use the gate level modeling also. So what you can do, you know the circuit for this half adder, so you just write XOR. So I will just write it here, the comment part. For sum, you just write XOR sum comma A comma B, and for this carry you can write and carry comma A comma B. Okay, so these two lines you can add in your gate level modeling. Okay, so this for gate level modeling and this is for data flow modeling. Okay, so in this way we can write this Verilog code and test bench. Okay, so we'll solve few more questions like full adder and remaining questions in the upcoming videos. Till that, thank you.